Welcome to the rabbithole.tech. In this video, we're going to prototype game logic using Python. The game Lucas's Tower may be more familiar to you as the Towers of Hanoi. French mathematician Edouard Lucas in 1883 may have created the game to show, irregardless the number of discs, the minimum number of moves required to win can be predicted in a mathematical way. Okay, let's start off by welcoming the user to the game. And, you can make this as simple or as complicated as you want. This is just a prototype, so we'll keep it relatively simple. Welcome to the game. And we'll throw in a new line character there. And we'll put in a divider of, say, 50 equal signs. There we go. And then let's display the title of the game. So we'll put in a couple of new line, and we'll indent. And throw in another new line. Yeah, we'll see what that ends up looking like. Let's see, and we're going to expand the tabs, which is the /t. And let's use 8 characters as our tab positions. And we'll put in one last divider. All right, and there you go. Okay, now let's run it and see what we get. All right, kind of don't like that. So let's add a couple more new lines. Run it. There you go. And I thought I would like a larger offset on the bottom. I don't. So let's clear. Whoops. Wrong window. Clear. And we'll run it again. And there we go. All right, let's move this out of the way. Okay, the next thing that we said we were going to do is get some setup information from the user. So we need to get the number of disks before we can really do anything else. So and we want to have options to get the number of disks. We want to have an option to display instructions. And we want to allow the user to change their mind and not play. And for this, what you'll want to do is have a while loop. And it can be an infinite loop. And it helps if I don't capitalize. All right. And you could easily put a counter, initialize the counter at 0 or at true, or Boolean true, and then at some point later set it to false. We're going to use it as true, and we're going to just break out of the loop when we need to. So since you know, what we're asking the user. Well, let's go ahead and put in user input equals input. Give them the input prompt, and let's see, we want to just how many disks? Let's just leave it at that. Let's give them a prompt or a help. Let's just say the valid values are going to be between 3 and 6 disks. Let's see. We know we want to give them the option of instructions. And the option to quit. Okay, and we'll play with that in a minute. So once a user has entered their response, we need to validate it. So since we're looking for a number or possibly a string, so let's make our first check to be if the user input is a digit. Okay, and if it is, and this returns a true or false, so we're just gonna that's all we got to do for our check there. And then if it is a digit, okay, then we want to get the integer value of the string. Just converting it, so I'm putting it right back into the integer value of the string back into our variable, and then that'll make it, you know, convert it into an integer that we can use in our math later. Now, if it's not a string, and we're going to add some more to this, but let's go ahead and get there. So if it's anything else, if it's not a digit, it's going to be an alpha character. So let's see. If we're there, we want to check to see if there's a quit. If user input equals q. Whoops, not to q. All right, let's print goodbye, a little friendly message. And then what we're going to do here is import, since we're leaving the program, we're going to import the Python sys module. So we can make system calls, and we're going to exit. And then let's go and take the slide that down. All right, and then the other option that we were giving, the user input equals I for instructions. You may want to do H for help, whatever. All right, and then here you can make this as complicated or basic as you want. We're just going to put this here for now. And let's just put go here. Okay, we'll just use that as a placeholder. Let's see, and then if, you know what, let's change this to an else if. And let's say if anything else other than a Q or an I that we're expecting, then we want to print invalid input. And then let's look at this again. All right, so if they enter an integer, let's say that you know, because that's what we are trying to get to. Let's check for the value, because we want to limit how many disks the user has a choice of, because we said 3 to 6. So if it's less than 3, or if the user input is greater than 6, then it's outside the range. So we want to print invalid number of disks. Okay. And then if it comes back true, then they entered the correct, you know, a valid number of disks. So now we can print, you have chosen to play with user input number of disks. You could also use a formatted string and put in the user input inside of curly braces, whatever you want to do. Tons of ways to do this. They're all going to look similar to this, but this is where you have some freedom. Let's save this, and we shall run it. And let's slide this up. All right, so Python app.py, not that one. Okay. And you can see, again, we welcome the user to the game. Here's Lucas's Tower for the title. And then how many disks do you want? And, you know, we just kind of threw this in here. So it's all on one line. Don't really like it, but whatever. We'll change it in a little, maybe just now. So I'm going to say Q to quit. So goodbye. All right, let's tell you what, before I move on, let's run it again. Actually, let me clear my screen. Okay. And this time, let's just go for for instructions, and whatever we would want to do there for instructions is good. And then it loops back around because, you know, we pressed an invalid value, or not an invalid value. We requested instructions, and so then once the user has read the instructions, the next thing that they'll want to do is go back and actually select the number of disks and understand, while they have a better understanding of what the game is about. So this time, let's just give an invalid input. We're going to say 1 disk, invalid number of disks. Let's pick a number above 6, invalid number of disks. Let's go with 4, which is a valid number, and you have chosen to play with 4 number of disks, and you guys cannot see the output. Okay, and so I don't like that sentence. Let's make some changes here. So let's first off change this, and it's always going to be a plural in our case here. Let's see, also it didn't break from that. So we want to break from our loop. We want to repeat the loop if they did entered an invalid number of disks. So we're good at that. We can always add more instructions later. So I don't really care about that. And tell you what, once we get out, well, yeah, that's good. Let's save that. Oh, I know. We wanted to add something here. So let's back that up and let's put in a tab. Let's tab to, and then let's drop down to a new line and let's try maybe 3 tabs, see what happens. And let's go over here, and we want this option to quit to kind of be at the same location. So we're going to go with 3 tabs, and let's expand tabs. Let's try 10. See what happens. Okay. Bring this up. I'm going to break out of it. Or no, because quit should break. Yeah, there we go. All right. Actually, let me clear my screen. And okay. So now you can see, and that looks fine. How many discs do you want? You know, that could change, but that's good enough for now. All right. I don't like that my input is right here. Oh, we didn't test the invalid character. Okay, earlier. All right, there you go. Quit. Let's go back up here. All right, where we have our options, and let's put in another new line, and we'll put in a colon and save it. Come back down here, clear our screen, run it. All right, now I have my input being down here. There you go. Quit. Good. Let's drop this down out of the way. And let's set the number of discs equal to our user input, because at this point, if we make it to here, we have an integer, a valid integer. Let's go up here and just say minimum number of moves to win is, and we'll do our little math. We're going to say 2 to the power of, you know what, we're going to do that down here. Number of discs. I could have done it times the user input, but we'll move it down here for now. Let's see. Oh yeah, -1. Let's give it a colon. Save it. Let's run it. Okay, and let's do 5 discs, 31 moves. There you go. the way. Now that we've gotten the number of disks from the user that we want, let's think about how we want to create the tower and keep track of what disks are in what position. So in Python you have lists, and if you think about the operations that we're going to be doing, we're going to be taking an element from one list and moving it onto the beginning of the next list, and kind of jumbling things around. But we're always going to be kind of working from at the ends of the disk, so it's a queue. And then Python has a double-ended queue called a deque, deque, and that's what we're going to use as our lists. And they have a lot of the same methods that a Python list has. But we're going to use that because it's optimized for popping the element out off of the stack, and appending. Those operations occur faster. So since that's the way that we're going to be accessing this list, it only makes sense to use that. So let's see. So we're going to have the number of disks. We're just creating a range for the list. Let's see. And as I said, we're using the deque. So we want to, let's see, it's part of the collections. So collections, whoops. All right, from collections, import deque. All right, and now it recognizes it. All right, so we're going to have 3 towers. So we're going to have 3 deques. And let's see, this one, we just want it to be an empty one. And the same with the last one. And let's see, all right, our when tower, and that's going to equal tower 0, which is this first deque that has the range of the disks. And we're just going to copy that. All right. And then let's initialize a move counter. Well, nah, not yet. So the next thing is, now that we've built this, we have to find a way to display. To display the towers, I'm going to create a new function. Actually, let's go up here. All right, so display towers. And let's just pass in the individual lists. And then let's take all right, so we're going to iterate. Well, as we think about it, let's think about the list of what each of them, each of the towers looks like right at this moment. So towers A, we're just going to say, let's just call it 0, and then 1 and 2. All right, and then in that, I'm going to just go down a line. All right, so we have 1 disk, none and none, 2, 3, 4, and let's just say we're going with 5. Okay, so this is what the tower is. You have a ring of 5 disks, then on top of that, or 5 width. Then you have a ring of 4 width, ring of 3 width, ring of 2 width, ring of 1 width. That way you get your pyramid shape. So that's basically what the tower looks like. And then towers 1 and 2, nothing's there. And what we're trying to do is end up building all the way over, having nothing in tower 0, and then having 1, 2, 3, 4, 5 in tower 2. And that's why down at the bottom here, I made what the winning tower would look like. It looks like a copy of tower 0. So with that, we need to, since as you draw in an ASCII or text kind of output, you're going to be writing this line first across all 3 lists. You're going to write across this list or this line, then you're going to write across this line, and you're going to write across this line, and then you're going to write across that line. So let's, okay, so let me slide this over one more, and this time, and I could have done that an easier way, but all right, so, and then this is going to be our index for each of the lists, okay, and then, there you go, and then what we want to do is iterate, and we want to put one, have what that value is for each. But once I make this first move, then it's going to look like this. And then it's going to look like that. Okay? So Python has a lot of ways of mapping lists together, but typically what it's going to do, it's going to take your first element out of list 1, and it's going to match it up with the first list of list 1 and the first element of list 2. So if I let Python do its thing, let's see, then it's going to want to stick 2 up here in the air, and then it's going to want to stick 1, ring 1 up in the air, and then there's going to be nothing down here, and that's obviously not what we want. We want to have the pretend that we're starting down here. So to do that, what we need to do is we need to iterate through these lines, and then we're going to have to do some manual manipulation to determine if element 2 should be lined up with element 0 of these, or element 4 needs to be lined up with element 0 of tower 1 and element 0 of tower 2. And then we may have a situation that looks like this. And actually, yeah, there we go. As we start moving things around. So then basically we'll want to not print this element, this row, until we're at index 3 on the display. And so basically, and it's going to be changing each time. So we want to grab element 0 instead of that, and we want to grab element 1 instead of element 4 when we get there. And for these, we want to print null or something that would look like a pole, if you will, and then these would be the disks. All right. So let me go ahead and I'll leave that up for just a little bit. All right. Okay. So for x in range, and we're going to go from logical 0 to the number of disks. And you know what? Let's. There you go. And let's. All right. All right, so we're going to take list A, get its length, and we're going to subtract the number of disks. And then we're going to add the index, the iteration. Okay? And then that's going to end up creating a value that will end up being the index that we really want. Okay, let's show what this would look like. So we have the length of list A, and list A length is actually 2, okay, minus the number of disks, which the total number of disks is 5. And then that's going to give us what? -3, right? Okay, so -3. And then we want to add the number of disks, x, which is our iteration through our lines of display, and we would be at line 3. -3 plus 3 is 0, which is what our test value will be, and 0 is our first disk. Okay? And then if you did, the 2 minus 5 plus 1, or I'm sorry, plus 4, then we're going to come up with a value of 1, which would be our next index. So it kind of starts with wherever the position is, or how many elements this has, minus the number of disks plus this incrementing number. Then that's how you get your difference, which will be the actual index of the tower disks. And that lets you know when you want to draw the representation of each disk for each tower. Okay, so let's just remove all of this because it's just getting in the way. And so once we've calculated that, then if a test val is greater than or equal to 0, because that's our index, and we only want to print something if we actually have an index of 0, 1, 2, 3. If it's a negative number, then there's nothing there to print. So then we'll say, and we're going to have to build a row. So we're just going to call this variable A. And we want this list A with the A test val. All right, so that way we're getting whatever calculated element number, and in the example that I used, 0 would have been the first when there's only, or when x gets to be 4, or actually the number 3, then that would be the 0 of list A. Okay. And then and that's when we want to get that value. And then else we want to have a null value, and this, like I said, would be where you would want to have some representation that's going to be a poll. And I'm just going to use the pipe character, but you can make it as pretty as you would like. Okay, so we did list A. We could go down the process of doing the same for list B. I would, of course, change all of that to list B, and then we would put in the same code again for list C. But repeating all of that code says that we probably should think about using a function instead. So let's do that. Let's get rid of that. And let's take this. Okay, let's call our new function get display value. Because that's what we want to do. And then we're going to need a list. And we're going to need the element that we need to work with in that list. All right. And just like before, whoops, we want to perform the same type of math. So obviously list A, instead of list A, we're passing in a list, so we just want to call it our in list. And then instead of a test val, let's just call this index, because that's really what we're generating. Oops. Index. All right. And then let's see, for A, all right, so this is what we actually want to return. And let's make sure, whoops, that we're returning a string. And not a number when it's an actual disk value. And then for here, when there's nothing in the position that we're printing, we want to return that pipe character. All right, so then we gotta call it. So A equals get display, and we're going to pass it list A and X. Okay, and then we're going to do the same for B. And whoops, list B, X. and again for C. And again, you know, you could pass this in a way when you iterate through, say, the arguments of the function or something to that effect, and you would do the same thing. I'm just going to leave it this way for now. Okay, so once we've done that, then we're going to want to actually print it or display it in some way. So we've done our iteration. Actually, let's see. Yeah, because we're going to change that. So each iteration, so we want to have the print up here in our for loop. And we're going to format it /t, t, and our third value. All right, format. We're going to say we want value A, value B, value C, and then let's expand our tabs, give ourselves some room in between, and we got 8. Okay, then display towers. Okay, so then we need to come down here, back to our main process, and we're going to display towers, and then this time we want to put in towers 0, towers 1, and we want towers 2. All right, let's save that, and then let's run it and see what we get. There we go. Let's see. All right, okay. Python app py. Whoops, let me slide this up so you can see. There we go. And we run it. We're going to say 5 disks. All right, so deque out of range. Let's take a look and see what that is. And that's in line 7. Okay, and I put in less than, and again, we don't want negative indexes, we want positive indexes. So we want index 0, we want index 1, we want index 2, so it's 0 or greater. Save it. Bring it up. Let me just clear this. All right, and then we run it again. 5, there you go. So we have our tower, our initialized gameplay, 5 disks, minimum number of moves to win is 31, and we have our disk 1, 2, 3, 4, 5, and none, and none. All right, let's move that down. Clean this up just a little bit and go back down here, and now we want to work on our loop to make moves. For the game movement loop, we're going to want to give the user the option to quit, display instructions as they want, as well as make a move. So let's just take this user loop that we had earlier, and let's turn that into a function. good. And then let me say that number of disks is going to be the result of the get user input. Before we do anything else, let's just make sure that what we didn't break anything. Oh, there we go. And run it. All right. Let's just say I for instructions that shows up. We'll do 1 disk, invalid number of disks. Then let me clear. Again, so you can see. There we go. And then we'll say 7 to exceed. And then we'll do quit, goodbye, and one last time, and this time we'll give it a valid number of disks. Okay, so this says that we are giving it an invalid type. Let's go back, and that is in line 49. Now, because I'm returning a string, and I want to return an integer. Okay. Or a none type, rather. And that's because I failed to think about that I am breaking from that loop. Let's see. Yeah, okay, so let's return user input. And that's probably all that I need to do. Save it. Come up. Let's clear this. Run it again. And this time let's pick a valid number of disks. 4 gave us the error. There you go. Now we have it. So it's showing us there are 4 disks. They're stacked. And we have the null poles. All right. Back down. Now we want to build our methods for accepting user input, how we want to make a move. Basically, we're going to say somehow we want to move from tower A to tower B or C. And you're just going to grab the top disk off of stack A, and you're going to put it on top of whatever may or may not be on pole B or C, depending on which one the user selected. As we look at our move loop, the thing that it does is it asks over and over, how many disks do you want? So we need a way of saying, okay, I don't want to ask how many disks do you want. Do you want to move? Or, do you want to make a move? Or what move do you want to make? So if our prompt selector zero, then we want to ask that. And otherwise, we want to ask what move would you like to make? Or make a move. And we're probably going to follow this kind of layout. Or they can have the option of displaying instructions or quitting the game. There you go. Actually, let's change this. Okay, so we're going to go from and to. Okay, next, let's take this welcome to the game, and I want to move it down here get that out of the middle of all of the functions that we have. Something that's bugging me right now is this prompt selector. Let's change that to make it a move counter. And let's see how many we have. Just those two. All right. Kind of make it more multi-purpose. Okay, let's change this to we're going to look for -1. Just I know that it's not technically move 0, and we're about to make a move when we hit this, and the first time that we're asking, really the game has not even started. So let's just call that -1, and we're going to pass in, where is it? Yeah, that's it. And we're going to pass in -1. By passing in -1, we let our function getUserInput know that this is a special run, and we're going to display the actual beginning where we ask for how many disks the player wants, and we won't ever need to do that after they've actually started their game. While we're on the subject of moves, let's think a little bit about what the move is in our tower structure. All right, so basically we're going to want to move from a tower to a tower. So it makes sense to make this into a list where we have tower A, tower B, tower C. So let's change that. That way we can reference by a key name. So we change that to curly braces. And at some point we're going to reference them by A, B, and C, and let's make that an uppercase. There we go, because we'll just convert to uppercase just to make the input easier. Next, let's create a list of possible moves. And for this, I'm just going to show you in case you haven't used permutations before. We're just going to do that. All right, so from itertools, import permutations. And then we want to, I'll show you what it looks like. So list permutations. And then we have a list of the objects, values that we're going to permutate, where you take one and you match it up with all of the others inside that list. And we're going to say we want a length of 2. And so what this is going to do is it's going to take A and B, A and C, B and A, B and C, then it's going to take C and A, C and B, and it's just creating a list like that. And there you go. A and B, A, C. All right. So then what we'll need to do is use those values and join them together so that we have a move combination from 2, from 2, from 2. So AB, AC, BA, and so on. And if that doesn't make sense, you'll see it when you actually are playing and need to make a move. So let's create those couple of lines. Tools, import permutations, and then I want to go down, and as I said, we're going to join them together. So let's say, really kind of doesn't matter where I put this right now. Let's put it here. All right, so for X in our list of permutations, C, and again our length of 2. So we're going to go through those tuples of AB, AC, and we're going to join them together. And let's actually put that into a list of valid moves. All right. All right, so valid moves, I'm going to have to append it. And so we're going to join X, element 0, and X, element 1. And then that'll create our list of valid moves, which are A, B, A, C. And if we ever want to change this, where let's say we want to have a 4th pole, and just to kind of make it a little something that most people haven't seen, you could add a pole D, and then the object isn't to get the tower rebuilt on column C, it's to get it to rebuild on column D in order to win. And does that take a different number of moves? All right, and we can kind of and we may experiment with that with when we have the computer doing the moves. Now let's just document that. See an issue I almost didn't catch where when we're looking at the towers, now that we're referencing them by a name. All right, so what the wind tower is going to look like Tower A at the start of the game. And we're going to need to do the same just below here. All right, and because we're calling that display towers, it's just with lists, we're still good, and we don't need to make any changes in our function. Let's try running it. There's your welcome message. How many disks do you want? 3. Okay, we got an error. And it's because I don't have my code, my join inside elements inside a list. Save it. Do it again. There it is. And this time, there you go. See, we've calculated the number of moves that the user should take, and we're displaying our 3 towers with the number of disks. Just to do that one more time, we'll show it with a different number of disks. Let's just do 6. And there you go. Now we'll pull this back down. All right. Now, every game can be thought of in terms of a loop. It doesn't matter if it is a first-person shooter or a board game. The players and opponents take an action. The action is represented on the play area. Check for a loss or a win condition, or you loop again and the game continues. First, with our game, we want to see how many moves the player is making, so let's make a move counter. We're going to initialize that to 0. And this is the same counter so let's work on our loop. At this point, we've just started the game, so let's initialize a move counter. Set it to 0. And then for our loop, we're going to say while the move counter is not equal to Q, which is for a quit condition, then we want to get a move counter. And we're going to set that equal to the get user input. We're going to pass in move counter. And that is where we have the get user input, and earlier we passed in a -1 because the game has not started and we're still in the initialization process. So we passed in a -1 there, and now we've begun the game because we've gotten the input of how many discs the player wants, so we know how we can set up the board. And then we get it again, we get user input, but this time we're passing in 0 as the move counter. So let's go up, get the user input. All right, so earlier we said if the move counter is -1, which we passed in, we didn't pass it in as a variable, we hard-coded -1. Then we ask the question, how many discs do you want? I'm going to move, let's move user input, let's move this, because this is really related to how many discs they want. It's a check after that. So let's move that up here. Okay. All right. Yeah, that's right. Okay, and then since we're looking for a value, let's return the user input here, and then that'll tell us how many discs the person wants to play with. And now we don't need this line. As you can see, it's grayed out. We're never going to get to that line. So we move that here, and then up here where they've entered a move, that's where we're going to do our check to see if the, and let me slide this up just a hair. All right, and down here is where we were returning the user input earlier, and as you can see, it's kind of grayed out. We aren't going to ever hit that. So we're going to delete that line, and we're going to return a value up here. So in order to determine whether we have a valid move or not, we're going to need to have this function, get the user input, determine what acceptable moves are. So we are going to, and there's all kinds of ways you could do it, but we're going to, or I'm going to, just pass in our list of valid moves that I created down below. So let's go back down here and valid moves. And then we're going to go back up get user input. Here we go. We're going to come back up here. And actually, let's, and by setting this list, I want to point out that it makes it so that that's the default. It's an empty list of moves, which is fine for when we just pass in a -1. We don't have valid moves yet because we don't know how many discs we're working with. All right, so now we do our check. Is it our first time through, or is it an actual time for a move? And we're going to exit that if, and we're going to check to see if the move, if it's a move, is it in our list of valid moves? So we're going to say user input. Let's convert it to uppercase. Is in moves. Then it's a valid move, so let's go ahead and set our move counter, or it's a potentially valid move, and plus or plus itself, move disks, and let's see, this time we're going to call a new function to actually attempt to move this disk. And so with that, we need to pass the input. We're going to keep it uppercase. You could convert it to yet another variable and then pass it in. I'm just going to do it this way. Let's see. And then if we move, and what I'm envisioning is we either return a 1, that yes, it's a valid move and we're good to go, or 0, it's not a valid move and they need to enter another move, and our move counter will increment by 1 if it's a valid move, and it'll stay the same if it's an invalid move. So now let's scroll down a little bit and let's create our function to move the disk. And remember, we were passing in the movement that the user wanted to make. And remember, that movement is going to be a string, and it's AB, BC, CB. Okay? So we want to get our move from is going to be movement element 0, and the move to is going to be our movement element 1. First thing we want to check is, does the tower have disks to move? Then if it does, whoops, move. If it does have disks to move, we're going to go in and we're going to say, does it have, let me put it here, does the destination have a disk, or is it empty? And then we'll stop there for right now. I'm sorry. This is actually a check for the disk size, which is going to come maybe the next level. Alright, so if we fail, the destination, or actually if this is a valid move, then we want to return 1. So let's see, so else towers move to, and here we're going to update the target tower on And from, we're going to get rid of that disk, the top disk. Why am I adding a T? I don't know. Top disk. All right. Let's see. All right, so we extend left, and we have to have that in a list format, so that's why I have it inside of square braces, and I just threw in the comma there in case there was ever going to be more, but there is not. We're only moving one disk at a time. And we're extending left, which is element 0. So we're making element 0 of our target be what we remove from. And then we return 1, which will increment our move counter. Okay, so to check, does tower have disks to move from tower? All right, so we say if length of towers, and remember, this is where it comes in handy. We named them A, B, or C, but our A, B, C is going to be our movement from. Move from. And is that length greater than 0? If it is, then we have a disk to move. If we don't, let's come down here. And we're going to say it's an invalid move. This tower, tell you what, let's put tower movement 0, and I'll go back and make that formatted string. Movement 0 has no disks. Formatted string. There we go. All right, and then remember, if we get down here to the end and we haven't made a valid move, we want to return 0. And this is showing us an error underlined because we haven't entered any commands in here. So let's go ahead and do that. All right, so in a similar manner, we got to see if this is empty. We want to check its length. Tower. And this time it's movement 2, or move 2. And is that greater than 0? If it's not, we want to print that larger disks cannot be placed on smaller disks. Oops. Okay. All right, so now we have that check. Okay. Now, by accident, I hinted at if we are able to make a move, we have to do another check. We have to see if the towers, if the destination is larger. All right. Okay, so we say if towers. Let's see, we're wanting to check our move from, and it's element 0 is less than towers. Where we're going to move to. And again, element 0. All right, then okay, so if there's no destination, we go ahead and make a move. If there is if there is a disk at the destination, we check to make sure that we're smaller, that we're moving a smaller disk onto the target disk, and if not, it's an invalid move. So we kind of exit fail and go down, fail down to here, and then we return 0. So then if we don't fail this check, then it's a valid move. So here we want to move again, and this is going to be the same. Okay, even though, yeah, that's going to be the same. And then we will return 1 to, again, to increment the counter. And this kind of hollers out that there could be a better way to do this with repeating some syntax there, but for our purposes this is good enough. Okay, so that finishes up our move disk. So let's go back to where we call it, and we can see that we call it and then we just return our move counter. Or if it's not a move, we check, did they quit? Did they press I to get some instructions? And let me paste in just some instructions here instead of still having instructions go here. All right, and then if they didn't hit Q, I, or make a valid move, invalid input. If they press X, Y, it's not valid for this game. So now we want to go back down to our loop, our game loop, and we've gotten a move. So let's display our lists, our towers, and we can just kind of copy this in here, and let's slide that over. Whoops. All right. So once we've displayed that, what the consequences of their move is. Let's check to see if there was a win or whatever. All right, so our win tower is a copy of what our original tower A looked like after they selected the number of disks that they wanted to play with. So to check if there was a win, we go if towers C equals our wind tower. Now we want to print out some stuff. So first we're going to say, remind the person, this puzzle could be, solved in, let's see, did I put a minimum number? Nah, I just calculated it. Okay. We'll just do that again. All right, and then those are moves. And we'll add an extra carriage or line feed, and then we'll go down and we'll say if the minimum number of moves, which, tell you what, yeah, okay, I'm using this multiple times, so let's turn this into a variable. Let's say, let's call it perfect game. Perfect game equals, do I still have that? Yes, I do. So we're going to call that perfect game. All right, and then where else did I use it? I used it here. Perf game, and then if perf game equals the move counter, solve the puzzle perfectly. All right, and then if they didn't, okay, they still finished it, so let's not be too super critical. So you solved the puzzle in move counter. Move counter. Moves. And then, once they've done that, then we're good, and they've done that. We've printed a message. Once we've printed the message, doesn't depend on whether they did it perfectly or not, so we can exit. Oops. And that is it. So let's save it. Now, yeah, that's good for now. We'll run it. Okay. All right, so we run it. We're just going to say 3 disks. We're going to move A to C. And as you can see, it kind of works. So we're going to quit and go back to our program. Okay, so let's kind of clean up that output, because it really just kind of keeps scrolling. So let's say at the very beginning when we run it, we're going to use that OS library that we have imported Let's see. Actually, we didn't import the OS, so let's import it. We're going to need it. All right, let's go down. And right before, when the game first starts, let's clear the screen. And we're going to use CLS if we're playing on a Windows system. Whoops. And Windows systems appear as NT when you use the OS name call. And if it's not, then, whoops, then it's going to be a Mac or a Linux system. So we use clear. That's our OS command to clear the screen. Now that just clears it when we first run it. And so what we want to do is clear the screen later up in our move cycle. So let's see, input. User input, so we got their input. Okay, and then we quickly do some checks and quick goodbye. Let's just throw it here. Yeah. But let's put it down at this level. Oh, copied it. All right. And let me just add another line. Feed in there. That's better. Let's see how that looks when we run it. All right, as you can see earlier, we just have this. So should clear my screen. It did. All right, so now I'm going to say 3 disks. Okay, it's not clearing there. All right, so let's stop. Let's go back and see where is a better spot to put that. Now, tell you what, I'm going to comment that out. I'm not sure that I even need that there at all. Let's put it up where we display our lists. And let's see, I do want it before I ask that first question, so we'll leave it down below and we'll try it here. All right, let's see, saved. Scroll it back up. All right, here we go. Let's quit this game. All right, let's run it again. Okay, obviously it clears the screen when it gets ready to say goodbye. All right, there we go. So now we have this. We say 3 disks, and there we go. Now the board is set up. So I say I want to move A to C. Boom, and there we go. It refreshed, and it looks more magical. It jumps. All right, so then we go C to A. I mean, not A. C to B. A to C. Then I want to move B to A. And then I want to move B to C. And then I want to move A to C. I'll tell you what, before I do that, let's go A, B. Oh, why did I do that? Okay. C to, because that's a valid move. Let's go C to B, which is an invalid move. Okay, I'm not seeing the invalid move, so we need to fix that. Let's hit I and see if we get instructions. I do see instructions. What's my move? What happens if I hit instructions again? I keep spitting that out. All right, so we're going to say, what did I say? B to C for the win. Boom. the puzzle could be solved in 8 moves. Solved in 7 moves, and I solved it in 8 moves. All right, let's go back and clean up some more stuff. Okay, so let's fix this. Let's still a Python library. We're going to go from time, import sleep. And that just helps keep our program smaller. We could, whoops, that was deque. Okay, and if we, just by importing the method that we need. And what we're going to do is, I think the best place to put this is when we draw. Where's my drawing? The disks. Move the disk. Is that it? Yeah, when we move the disks. Okay, larger disk cannot be placed on a smaller disk. We want to let that sit there for a couple seconds. And we'll just do 2 seconds. And you know what? Let's make this a variable sleep var. And I'll initialize that up higher. And the execution, or earlier. And then let's put this here. Again, kind of a warn message. That's probably the only 2 places we need it. And then let's initialize. Let's see, we're getting. Let's do it after all of our methods here, where we're initializing some other things. Actually, it'd be better to put it up here. All right, it's not a variable that it's more of a constant, actually. All right, let's run this. Okay, and then we say 3. Okay, and let's see where we were seeing some things. Let's go to try and move an empty disk onto a full tower. Oh, tower B has no disks. Okay. So we can't move from there. I could write a better error than that, but you get the idea. So again, move from A to B. Now let's try A to B again. Larger disks cannot be placed on smaller disks. All right. So, and actually we want to stick that over there. Then we want to do, you know what? Let's do the instructions. There's my instructions. I can hit instructions again. It still does that. If I put in, you guys can't see it because of how my screen is positioned, but let's give a valid move, A to B. That clears our screen, and now we're back here. So earlier when I was seeing the instructions and I needed to put in a valid move, I could still see what the play area looks like, so I could be able to pick tower A, B, or C. Do we need to see if it wins? Don't think so. Let's go ahead and quit. And that's it. So, some other things that you could do with this is obviously you could keep a record of the moves so that you can display what the winning combination is. You could also, let's see, offer hints as to what the next move might be. Maybe you give the person 3 hints, or 1 hint, or whatever, some kind of a variable there. You could also make it where if they make a move that would not be in the perfect movelet orders, that would be an instant loss. So there's all kinds of things that you could do to this to adjust how the play actually works. But I hope you enjoy this, and the next video we'll look look at letting a computer solve this, and that shouldn't be too terrible. At least I hope not. All right, so see you next time. Thank you. If you like this video, please hit the like and subscribe buttons. Also, reach out and let me know what you did or didn't like about the content and video. I look forward to presenting more rabbit holes in the future. See you then.